Dear ladies, dear gentlemen, I'm very delighted to address this day, this distinguished audience, and share with you my thoughts on sustainability practice, specifically in a context of urban planning and urban risk management. What I would like to emphasize in my talk is the role and the function of science in designing sustainable futures for urban areas, but even beyond for societies as a whole. When we talk about sustainability, I think it's important first to emphasize what this term means, because it has been used so often in different contexts that it's important to have a common understanding. And in my view, sustainability means that we preserve the humane living conditions for all human beings, whether they live in the present or whether they will live in the future. And humane living conditions include that they have the ecological conditions that would provide humans with all the services that ecosystems can provide. But beyond that, it also means that we feel responsible as humans for the other creatures that co-inhabit the planet with us. It also includes that we provide enough goods, services, food, products to all human beings so that they can have access to all the things that they need to meet the basic needs of their lives. And it also includes the social aspects that are very important for humans to live together in peace, to have means of non-violent conflict resolution, and that for each individual there is the opportunity to live according to his or her preferences, to live according to his and her aspirations, as long as those aspirations do not violate the rights of others. So that's basically what sustainability means. Of course, this is a very broad concept, but it's also very clear that we want to preserve the conditions. We don't want to preserve the structures of today. We don't want to preserve nature as it is today, because it will always change. But we will preserve the conditions that allow us to live in a humane society. Another thing is very important at the beginning to stress that that's the main objective of what we'd like to do within sustainability practice. What is needed to do that? And the main thing is, and my central word here is integration. Integration means that we bring things together, that we emphasize relationships rather than isolated phenomena. And integration here means specifically 4 things that need to be integrated. The first thing is technological change. Our society is really imprinted by technology. I mean, that's part of the human evolutionary advantage, that we are able to use technology for our purposes. And that's not a bad thing. I mean, sometimes technology is seen as the culprit in all of that. Of course, it has also had its impact on destroying much of Earth's living systems, but it also is an instrument for preserving it. But what we do need is a humane, to repeat that word again, evolution of technology, and that technology is being diffused all over the world. The second point is that we need an economy or an economic structure that really supports that kind of humane conditioning. And so it means new business models, new ways of developing markets, new constraints on the markets, but basically that not growth is a means in itself or an end in itself, but rather, if any, a means for reaching more humane living conditions. So it's very important to change our priorities here. So the humane conditions are the first priority for all economic activities. And if you can reach this by more growth, that's fine. If you can reach it by other means, that's fine too. So we should be very careful about not confusing means and ends. The third thing, which I think is very important, is that we have right regulatory structures, right political incentives that gives us the drive and also the energy to move towards transformations for more sustainability. And so we need positive incentives for these kinds of transformations and negative incentives for staying within a system that is not sustainable. And that's very clear, for example, in the energy field, where we need to transform our present energy systems from a system based on fossil fuels to one that will be based on renewable energy. And lastly, and not at least least important, actually it's very important, is the issue of human behavior. And at this point, our behavior is really based, at least in the Western countries, on a high degree of consumption, a high degree of use of resources that very often are not renewable. It's based on a lot of waste, emissions, pollution, all of those things that have no future in a sustainable world. And so we need to change behavior. So that's the last thing that I think is extremely important. And that behavior includes individuals as well as collective entities like groups. Now, what does that mean for urban development? Well, very often urban development has been compartmentalized. So we have a technological development specifically in housing, but also in technology for heating, and technology for mobility, and technology for security. I mean, all of kind of things there. We have basically a market economy where profit seekers can have a good market in terms of real estate. We have a governmental policy that basically just supports housing, supports very often urban sprawl, but does not look really into what's good for cities and what's not. And then the behavior very often is that in the cities we are alienated from the natural resources from which we actually live. And then there's a lot of incentive for creating a lot of waste, for creating a lot of pollution, and all of that, of course, is not in line with sustainability practices. So what's needed? Needed is that we integrate these four things, and integration always needs a common goal, and a common goal, as I said, is to preserve and to also to create humane living conditions, and then to ask ourselves, what does it mean for technology? What kind of technology is needed? Where should we put money into? What kind of technology should not be supported? The second thing is, where are appropriate business models? Should we have more societies and assemblies that are non-profit oriented? Should we have other kind of common pool resource management methods? So there are a lot of things that could we do specifically in urban context. And then in the field of regulation, housing regulations, building codes are basically created at this point to be efficient. But what we need to have is that they need to be effective in terms of a humane development. They need to be resilient in light of all the major challenges like climate change and others that we will face in cities. And they also need to be fair. They need to be social just, so that it's not just for the rich, but also for the ones that have less income and less opportunity than others. And lastly is behavior. So we need to be sure that our behavior is in line with the planetary boundaries, as John Ruckstrom has called it. And we understand that there is still a lot of room for personal happiness, for individual development within the planetary constraints. And I think that's something that we all need to learn. Now, what I would also like to focus on, and that was I was asked to do, is to say, what is the role of science in all of this? And of course, science is an activity that tells us a little bit about what is true, what is the evidence about our actions and the likely consequences or implications of our actions. And that's very important for sustainability because, as we all know, we are living in an environment that's very complex and that it's not easy to understand. So we need scientific inquiry to give us a better understanding about causal or functional impacts within complex systems. So that's the first very important part, and I call this the analytic part of science. The analytic part is really giving us better information, better knowledge, better insights about the impact of our action. Of course, that's not all what analytic science can do. Of course, you also look into black holes or in other kinds of things that are just curiosity driven. But nevertheless, in terms of sustainability, specifically in urban context, it's very important to say, if we do X, what do we expect? Is it effective in terms of sustainability? What kind of side effects do we expect? Is it resilient in terms of that if stress is coming, that it will still function well? Is it socially just towards those who will be affected by the changes? All of that are very important questions, and these questions are not very well answered by intuition because intuition is not very good when we deal with complex issues. So this is the first thing, what I call analytic part of science. The second one is what I would call goal-oriented science. And goal-oriented science means that we are looking into scenarios, into horizon scanning, into different methods of shaping and designing the future. And their science has a little different role. It's not just analytic. It's what we try to do as scientists there is to say we have a specific goal, like make a city energy or climate neutral in the year 2040 or 2050. So what does it take to do so? What do we have to do? What are potential options? What are the side effects of these options? And there, the analytic and the goal-oriented actually go hand in hand. So this is a very important element. And their science is always fine. It's looking for situations and for solutions that provide answers to pre-given goals or problems. So it's not value-free, so it's very clear we want to accomplish something. So there is a normative narrative behind it, for example, a narrative towards sustainability, a narrative towards a sustainable city, towards sustainable mobility. And then we asking the question, what can we do to accomplish this, and what are the side effects of doing this? And that's not always easy because, as we all know, if you do future assessments, we don't know all the context conditions that have an impact on these various consequences, yet it's the best we do and best we know. And we can do, of course, experiments. We can do things that we call living labs, in which we try on a small scale what would happen if we do X and Y. So all of these things help us, and there are a whole set of new methods out there in science. As I said, horizon scanning, scenario analysis, visionary narratives. I mean, there's a whole issue of very different things that we can do in order to make sure we use the best of science, the best of insight, also on rigor and methodology to inform the public, inform policymakers, inform people about what to expect when they do X, Y, and Z, because we cannot afford in a world today just to do trial and error, because if we do the wrong thing and the error may be too costly really for us to accept. So this is the second part, goal-oriented. And then there's a third part to science, which I would also like really to stress, and that's what I call catalytic knowledge. So it's analytic, goal-oriented, and catalytic knowledge. And if you are somehow remembering Chemistry 101, a catalyst is a chemical that really induces or helps two other chemicals either to combine or we have a common impact. Um, and the catalytic scientific approach is one in which we help the transformation to happen. And that, of course, is a different type of science. It's much more the process-oriented science. And process-oriented science means that we're looking into the processes, for example, of democratic decision-making, or of how decisions are being made in urban centers. Who makes the decisions? Who is responsible for what? What kind of institutions are in place? And all of that is very important because, even if we know what's good for the world, even if we have good options, they still need to be implemented. And very often we know that things that we think is good are not implemented. We can look at ourselves. I mean, a lot of us eat too much or drink or smoke, all knowing that that's not good for us and that we all have the intention not to do it. Well, we have neither the will or the power or the agency to make changes. And the same thing is true for urban centers, or even for whole societies. Even if we know what we should do, it's not always done, and very often it's not done. And so what we need to say is how can we reform institutions? How can we inform decision making? How can we inform the way that human judgments are being made and implemented, that really that what we want is being done? And that's what we call catalytic science. It's more social science, and it's basically that social science has become the architects and designs for decision-making processes. And in a modern, specifically democratic world, it's not all the countries are democratic, but specifically the democratic world, this also includes something what we call inclusive governance. It's not just that there are decision makers out there and the ones that are being affected by the decisions, but those ones that are affected also demand, and I think it's also a good idea, to be part of the decision-making process. But that needs to be organized. That's nothing that comes by itself. And then we are in the realm of deliberative democracy, of participatory decision-making. And that is an art in itself, and it's also a science in itself. So we need to design good ways of how to include stakeholders, how to include the citizens that are affected, even if they're not organized, into the decision-making process without having a decision-making process that lasts forever, or that really runs into paralysis, which is seen very, very often. So is a very important element in which science is needed. And science really means rigorous methods to find out what functions and what doesn't function, what really leads us to a better decision-making process and what does not. And so we need to have good empirical data here. We need to make sure that empirical data is also processed by the best whatever statistical methods, and that we have good theories behind it. So it's not just an art. Yes, moderation is an art, and very often designing something is an art, but then we have to prove whether it works. And that's not an art, that's a science. And so my view would be that we say it's very important that we have a lot of resources being reserved for this catalytic function of science. Because when we look at the urgent things that we need for transformations, we are not having so much time to do this. We're pretty sure that if we don't get climate change being really managed within the next 20 years, we'll probably lose it. And then, of course, we know the consequences would be dire. So in that sense, we need this catalytic aspect of science. Now, what does it mean altogether? I started out this little lecture by saying integration is a magic word here. And the same thing is true for science. We need those three different functions of science working together. We need the analytic part of science that tells us much more about causal and functional relationship within complex systems. As I said, that's not trivial, and intuition very often fails here. Even the good, let's say, will or common sense very often defeat good thinking. And we need the best methodological work here. It's basically value-free, which doesn't mean that people don't have values, but we should be open for surprise. Secondly, we need that being integrated into goal-oriented, because a lot of these functional relationships are part of our goal-oriented decision-making process, in which we have to know what are the best scenarios to reach a predefined goal. What kind of options do we have? What are the side effects of these options? But also, how effective are they in the end? And that again is a big scientific question. It's very much related to policymaking, because policymakers need to know which option has what kind of impacts. And thirdly, we need to find out how all of this can be integrated into a process that gives actually credence to evidence. And we can see that in many countries, even in a lot of democratic countries, evidence is not used as a guideline or as an orientation for decision making, and fake news are running the show. So we have to be very clear that we need to have good processes that give evidence a place it needs, but it's not just evidence. So we need also other types of knowledge that is very important, experiential knowledge, tacit knowledge, and we need to integrate, of course, the various preferences of different people. And to do this in a way that it really becomes effective, as I said, efficient, resilient, and fair for everyone. So in the end, we need to have a kind of integrative scientific approach that links the three elements of science: the analytic, the goal-oriented, and the catalytic one, into a single kind of scientific design. And that, I think, is one that is definitely needed in order to reach the overall integration that I have started with in my talk, and that's the overall integration of technology development and diffusion. Secondly, new types of business and economic models, effective and fair regulation, and behavior that goes along with the goals of sustainability. Thank you very much, and I'm looking forward to the discussion.